The nightly ETL crashed with a statement reached its statement timeout error after hitting the default 5-minute limit, leaving your reporting table empty. What broke? A stored procedure processing millions of rows without a single commit. Let's explore. You'll learn how to create and use stored procedures and user-defined functions in Snowflake, with a focus on real-world scenarios. We'll cover Snowflake scripting syntax, debugging techniques, and common pitfalls. With Snowflake, you can encapsulate business logic using SQL. Stored procedures allow you to write procedural code that executes multiple SQL statements, while UDFs return a single value per call. Snowflake scripting is the SQL-based language that adds variables, loops, and conditionals. Think of stored procedures as a recipe for the kitchen staff, and UDFs as a reusable spice blend. Both are created and run directly in your Snowflake database, making them perfect for ETL, transformations, and automation. Let's create a simple stored procedure that greets a user and returns a varchar and a scalar UDF that calculates tax. Always use create or replace to avoid errors. You can call the procedure with call and the UDF with select. Version control your code using Git. Here's the code. The procedure uses Snowflake scripting with a begin, end block. The UDF is a simple SQL expression. Call the procedure with call and use the UDF in a select statement. Snowflake scripting introduces variables, cursors, and control flow. Use declare or let to declare variables. Cursors iterate query results row by row, and a for loop steps through each row, where you can update the data as needed. Always close cursors explicitly to free resources. This procedure processes pending orders. It declares a cursor, loops through each order, updates inventory and order status, then returns the count. Note the explicit close and the use of for rec in cur. Cursors process rows one by one, causing slow execution and high credit usage for large datasets. Replace the cursor loop with a single set-based update using a subquery to update all rows at once, eliminating the row-by-row overhead. Only use cursors when row-by-row logic is truly unavoidable. Here's a SQL UDF that calculates business days between two dates, excluding weekends. It uses the generator function to create a series of dates, filters out weekends, and is called in a select statement to return the count. The UDF uses DAT-DIFF for the day range, then generator to produce row sequences, with DAT-ADD creating each date. DAYOFWEK filters out weekends. Use it directly in a select. Avoid UDFs in where clauses on large tables as they may prevent predicate pushdown. A UDF in where forces a full table scan because Snowflake can't push down the predicate. The fix wraps the query in a subquery, computing the UDF as a column first, then filters on that column, allowing pushdown to work. Let's build a real ETL procedure that extracts raw sales data, stages it into a temp table for transformation where we calculate commissions, then loads the result into the sales reporting table. It also logs each step with timestamps and row counts. This procedure uses a temporary table for intermediate results, then inserts into the reporting table and marks raw data as processed. It includes exception handling that logs errors. Use temporary tables to avoid locking and reduce resource contention. JavaScript stored procedures offer more flexibility for complex logic or external API calls. They use Snowflake's JavaScript API calling Snowflake execute with a binds array, handling errors with try-catch, and returning a string result. Here's an example that enriches customer data. The JavaScript procedure simulates an API call, then updates the customer table using a parameterized statement. Use try-catch for error handling. Prefer Snowflake scripting for simpler tasks. JavaScript is for complex integrations. In JavaScript procedures, all variables must be declared with var, let, or const. Forgetting that, like we see here on the left, causes a compilation error. The fix is simply adding var before the variable, which declares it and allows the procedure to compile. Debugging stored procedures can be challenging. Use system $log to insert log messages into a table. query the query history view to see executed SQL, and for JavaScript procedures, use console.log to output debug info. Here's a procedure with logging. It inserts timestamps and messages into a log table at key steps. After calling the procedure, query the log table to see the execution flow. Remove excessive logging in production to avoid overhead. This is the chain reaction that unfolded. The procedure processed millions of rows without explicit commit statements. Each iteration added to the same transaction, which grew too large and hit Snowflake's default statement timeout of 5 minutes. The result? The entire ETL failed, leaving the reporting table empty. The fix was to add explicit commit statements after each major batch operation, breaking the long transaction into smaller chunks. Additionally, we increased the timeout using the statement TIMEOUT and SCUNDS parameter. This resolved the timeout, and the procedure now completes reliably. Here's the exact mistake from the incident. No commit inside the loop, so the transaction grows until it times out. The fix, shown here, adds commit right after each update in the loop. That keeps each transaction small, preventing the timeout. Follow these best practices. Prefer set-based operations, use temp tables for intermediate staging, limit DDL statements, mark UDFs as immutable or stable to enable caching, and always use exception handling. Also, test with production-scale data using zero-copy cloning. Here's a set-based update that replaces a cursor loop. Also, marking a UDF as immutable allows Snowflake to cache results, improving performance. Always test with production-scale data. When a procedure fails with a timeout, first check its transaction handling. Add commit statements after large operations. Increase the timeout using the statement timeout in seconds parameter. Use logging to track progress. Use these commands to increase timeout, create a debug log table, insert log messages, and query the query history for your procedure. This helps identify bottlenecks. Let's recap interview questions. Stored procedures can perform multiple operations and modify data, while UDFs return a single value. Use exception blocks for error handling. For performance, mark UDFs as immutable and avoid using them in where clauses. FAQs demystified. UDFs can't call stored procedures. To pass arrays, use JSON or a temporary table. Snowflake supports SQL, JavaScript, Python, and Java for procedures and UDFs. To recap, stored procedures and UDFs enable reusable code. Use Snowflake scripting for most tasks. Prefer set-based operations over cursors. Always include error handling and logging. Mark UDFs with immutable or stable to enable caching. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.